Alright, this is going to be a simplified version of how to connect your tether switch without all the ands, ifs, and buts and caveats. So, basically, one of the leads from your tether switch connects to the ground wire on the coil. On my coil, that is a black wire with a yellow tracer. It can be located coming directly out of your ignition coil and should be fairly easy to find. It will be connected to ground, so that should give it away. The other wire from your tether switch needs to connect in to the ignition coil wire where your kill switch from the factory connected. On my jet ski, that is a blue wire. And well, YouTube, I finally had a chance to take the X2 out and test ride it yesterday. I'm not sure when that video will be out, but I got to burn about 1/3 of a tank of fuel in it. Had a few little bugs along the way, but you'll just have to watch the video to see what happened there. Anyway, what this video is about is actually the tether switch that I installed on this. One of my viewers, Alex, wanted to know how to wire this and basically how I installed it. And so I thought I'd do a quick video on that. Hopefully I can make it a quick video and it doesn't turn into something too drawn out. So this is the particular tether switch that I got from Amazon. It was fairly inexpensive. So to shut it off, you can pull this off or you can push on the button. So when this is installed, you can push on that button and it will shut it off. A lot of these older jet skis didn't come with any kind of tether switch. If your throttle cable ends up breaking and sticking, or if something jams up and you fall off, or if you fall off at a high speed, the jet ski can end up quite a ways away from you, driving away from you, or running into something or someone. So it's a good idea to install one of these switches so that when you fall off, your machine shuts off. The trickiest part of this whole thing for me was actually trying to decide on a mounting location for the switch. And I actually used the old strap holes. So I removed my strap because I never plan on using that, which left me with one open hole on this side, which I plugged with epoxy and some fiberglass. It's not structural, so you can kind of use anything that'll keep the water out over here. And then over here, I conveniently used the switch to plug this hole off. Once I decided on mounting the switch in this location, the trickiest part of it was that I had done a fiberglass repair previously, and the fiberglass here was fairly thick, so I had to sand it down. If you're using the factory kind of mounting location, you may not have to do any sanding, but just keep in mind that you might actually have to get some sandpaper, go in behind here. It's not the nicest place to reach into, but if you remove your filter or whatever kind of air stack you have on, then you can reach in there and just kind of sand around the back of this hole here a little bit. Regardless of the thickness of your fiberglass or whatever panel you're mounting it in, you want to make sure that the nut goes on far enough so that it's flush with the end of the threads. If not, you're going to have a very hard time installing this lobster claw or whatever they call it. I'm going to call it a lobster claw. So yeah, you don't want to be out in the water freezing to death trying to get this on there, so you want to make it as easy as possible. If you're having a difficult time getting it off when you're standing there on solid ground, then you're going to have a really hard time when you're floating in the water beside your jet ski. So this next part is probably what's scary for most people, but there's nothing scary about it, and it's actually very straightforward. The way that this switch works and the way that your kill system works on your jet ski is that you simply ground the primary side of the ignition coil. Now, you don't have to know what that means in order to do this, so ignore that if it scares you at all. Basically, the kill switch has two wires. One of them is going to be connected to the ground, so you need to make sure that it's actually grounded. You have to keep in mind on a jet ski that not all of the metal parts are going to be grounded, so I'll grab my meter now and show you guys just so you know what I mean. Alright, so here I have my multimeter. I've got an ohm setting and a beep function. Not everybody will have the beep function, but if you do have that, it's pretty handy. When you touch the leads together, if there's continuity, it will beep. So if I touch this on the engine here and on the steering, there's nothing actually connecting it, it's not going to beep. So not every metal part on here is connected. So we'll touch here and it should beep. My black lead is now on the ground of the battery and I don't have a connection there. Interesting. How is my engine not grounded? Please stand by. We are experiencing technical difficulties. I'm experiencing some technical difficulties trying to show you guys how I hooked up this kill switch. And I think I've figured out why my starter has been giving me issues. So you haven't seen the video yet because I haven't published it, but the X2 has been giving me a few starting issues. I replaced the starter solenoid on it and redid some wiring and foolishly didn't test it very well before taking it out on the water. So I think by trying to show you guys this, I actually figured out what the problem is with my starting system. So I'm sitting here telling you guys not to just assume that you have a good ground, and well, I made the assumption that I had a good ground for my starter system. I'm touching the ground terminal with the black lead, and if I touch the ground at the starter, so there's a ground wire that goes right to the starter, you can hear that is beeping. Now, what would happen if somebody foolishly powder coated their starter and installed it powder coated? Well, it might not have good connection to the engine, and that would mean that the exhaust wouldn't have connection, and that the base bolts wouldn't have connection, and that the relay would not have a good connection. Good news, I think I've figured out my starting problem. We now return to our regularly scheduled program. As I was saying, don't just assume that you've got a good ground, actually check. So the switch comes with two wires. Basically, this switch either has continuity or no continuity. So the switch is either open or closed. And so it doesn't matter what color is there, it doesn't matter what type of connector there is. All that matters is that one end is connected to the ground from your coil. In my case, on a 1990 X2, the wire from the coil that is black with a yellow stripe is connected to a ground on the frame. And that's where I piggybacked and connected the black wire from the switch. It had an eyelet connector, so that's the one that I chose to use. It doesn't matter what color the wire is from your switch. If it has an eyelet connector, it's pretty easy to connect it where the coil connects, so that's what you want to do. So to summarize on that point, one of the wires from your kill switch goes to the ground wire to your ignition coil. The other wire from your kill switch, in my case, it is white with a bullet connector. But regardless of what color it is and what type of connector it has, the other wire from your kill switch should be connected basically to wherever the wire from your thumb kill switch connects. So to figure out which wire is from your kill switch, it's fairly simple. You can do it in a couple of different ways. We have basically 4 wires coming down. In my case, we have a white and an orange, and a blue and a black. The white and the orange go to the starter relay. That is part of the starting circuit, so we can eliminate that. We know that those wires are not it. So we can basically say for certain that the blue and the black is from the kill switch. But so that we're not just guessing, what I'm actually going to do, I have my multimeter set to the beep function. So when I have a connection, I get a beep. So what I do now is I connect my multimeter to the black and the blue. Doesn't matter which lead goes to which. And then I hit my kill button and the meter should beep. Alright, so now we know which wires come from the kill switch. What we want to do is we want to figure out which wire goes to the ground and which wire goes to the ignition coil. So that you naysayers out there don't think that I don't know what I'm talking about. I do realize that this uses a kill switch relay, but that hardly matters. It still goes through the relay to the coil, so keep your comments to yourself. Anyway, now that we know which wires come from the kill switch, we're going to set those wires aside, and we're actually going to test the other wires now for continuity. So what we want to do is we want to test to see which wire is ground and which wire is to the coil. So to check to see which wire is to the ground, we connect first to the blue. I'm going to try that one. I connect the blue wire to the ground and I get no beeping. So that means the other wire is probably my ground. And it's black, so that indicates that it's ground anyway. But I connect to the black wire and now touch the ground. And quite clearly, this is the ground wire. A very simplified version of this is, as soon as you connect the blue wire to ground, the engine will shut off. This happens through the kill switch. We're going to make it happen through the toggle switch. So basically what we're going to do is we're going to cut into the blue wire. I decided to cut into the blue wire on the switch side. I suggest doing it in a place where you can get at it easily and you can see if there's a problem in the future. What I did is I spliced into the blue wire and I spliced into that with a bullet connector. That bullet connector can now connect to the other connector from the tether switch. Alright, this is going to be a simplified version of how to connect your tether switch without all the ands, ifs, and buts and caveats. So, basically, one of the leads from your tether switch connects to the ground wire on the coil. The other wire from your tether switch needs to connect in to the ignition coil wire where your kill switch from the factory connected. Alright, now I'm going to go into a little bit more detail and explain a little bit more thoroughly how this system works, and perhaps if you're having troubles this can help you diagnose it or figure out your system, but it's fairly straightforward. So if you ground the primary side of your ignition coil by connecting this blue wire, it will shut the engine off. So anytime the engine is running, if you connect this blue wire to ground, it will shut the engine off. So what happens is, normally from the factory, this blue wire is connected to that wire from the coil. This wire goes up to the kill switch, back down from the kill switch to this ground. This ground goes to the engine and is grounded to the engine. So what happens when you push the kill button, you're basically shorting the primary side of the ignition coil to the engine, and the spark goes through the switch to the engine instead of going to the spark plug. That's a simplified version of how it happens. It actually stops it from sparking before the spark actually happens, but yeah, anyway. To make things a little bit more complicated, in my case, they actually have what they call a kill switch relay, but if you don't want to pay attention to this at all, basically if you connect it the way I said, then it still works. But the idea behind this is a bit of a safety device in two ways. If you're riding along and your throttle sticks and you hit the button, the engine could be going quite fast, and basically if you hit the button and don't hold it, the engine might not shut completely off, and if you let go of the button, the engine could actually fire up again. So what this kill switch relay actually does is when you hit the kill button, it continues hitting the kill button for you, basically, until the engine is completely stopped, and then it opens back up. My father used to tell me a story about driving through the Air Force base back where we lived, and they had old cars, and what they would do is actually drive through revving the car really high in second gear, turn the ignition off, hold the throttle wide open, and then when they were almost to a stop, you would shift into first gear to get the engine spinning nice and fast again, and turn the key back on. And in one instance, he actually had the car backfire so hard that it blew the exhaust off the car and made for an exciting situation. So that's the other reason why you would want a kill switch relay on your engine, because if you're riding along and you hit the kill switch button and you let go of it before the engine's completely stopped, it can do some pretty crazy backfiring and blow a coupler off or blow a seal out of your engine if you're very unlucky. So basically it's a safety feature in a couple of ways. Don't you just love it when your GoPro shuts off in the middle of recording without any warning whatsoever? It's fantastic. As I was saying before I was rudely interrupted, a kill switch relay system isn't much different than a normal kill switch system. A kill switch relay is actually quite clever, and when you understand what it does, it might make you grin a little bit. It does for me anyway. When your engine is running and you hit the kill switch, basically what that does in an ordinary system and in this system is it sends the power from your ignition coil through the kill button to ground. In this case, what they do is they send the power through the kill button, but before it goes to ground, it actually goes through the relay. The power that is going to ground through the relay energizes the relay and switches it on. So even if you let go of the kill switch button, the power that is going through the relay is energizing it and keeping the switch on. So it's keeping it grounded even if you let go of the button. Then what eventually happens, as soon as the engine is going slow enough that it's not making enough power for the ignition coil to fire, it's not making enough power to keep the relay engaged, and so the relay disengages, and you can then start the engine again. I know this is probably way more information than anybody wanted to know. All anybody wanted to know is how to hook up their kill switch, but I find this stuff kind of interesting, and sometimes understanding how a system works can really help when you're trying to diagnose something. If somebody just tells you this wire and that wire and check it, and then you start looking at the system and it has different color wires, then it can be a bit of a head scratcher. And on a lot of these older boats, people have messed with the wiring harnesses and whatever. So if you understand the basics of it, it can make it a lot easier to kind of figure out and sort out. Well, Alex, I hope that this video wasn't completely over the top and you found it interesting and informative. If you have any questions or need me to clarify something, feel free to leave a comment or a question in the comments and I will do my best to answer. Hopefully some other people find this helpful along the way. It's really not that complicated of a system if you basically think of it as a roadmap and follow where the power goes. It's not really that complicated of a system. Anyway, that's going to do it for this one. Thanks for watching, and I'll see you next time.